Hi, this is Synthchaser from synthchaser.com. Today we're going to be repairing the second of two ARP Pro Soloists that used to belong to Bernie Worrell. This one, the case is a little beat up and it was missing the sides. This one we're going to be mostly concerned with getting it working perfectly, but less so on the cosmetics because the case is dented up. We're going to be taking the side panels from the other Pro Soloist, putting them on this one. We're going to be taking the switchboard, which isn't painted, from this one, and we're going to be putting it in the nice looking one. And we're going to be swapping this white switch from that board onto here, because this one is cracked. We'll replace this one with a black switch. And we'll be refurbishing the keyboard. We'll be recapping the whole synthesizer. We'll be replacing the sliders since they're pretty stiff and no doubt very dirty. So we're going to put in the illuminated sliders, the purple LED sliders, because it's Bernie Worrell's. And so let's get started by taking this apart. In the previous video I took the bottom panel off, which gives us access to all the guts. And the first thing we're going to do is take out the keyboard. Then we're going to remove all the circuit boards, including the power supply. And we're going to set them up on the bench after we recap them. So first I'm going to pull everything out of here, and then we'll begin the recapping. This touch sensor bar has a tiny bit of life in it. If you push it with a really hard amount of force in certain points along the bar, like I'm talking huge amount of pressure, you can get some response out of it, but it is way past its prime, and we're going to remove it. Normally, to get this off the Pro Soloist, you would have to desolder it here to remove it from the board. But because I'm going to be replacing it, I'm just going to cut it off with some wire cutters and set the bar out of the way, and we'll rebuild that. I also have a replacement available that you can buy on my website, synthchaser.com, and we'll continue to get these other boards out of the synthesizer.
So I'm getting the boards out of this Pro Soloist, and kind of wonder what was living in there.
Now I've got all the boards out of the Pro Soloist. Here we have board A with the sliders, and board C with the voltage controlled filter. And I've taken the output jack off, and I've soldered the high output through the resistor to the low output, which is this jack. The RCA jack for the high output would be harder to take off, so I've left that on the case. Here we have board B, which is the envelope generator, and board D, which is the touch sensor effects board. Board E is on the bottom of the keyboard, and in this case, in our previous one, move this out of the way. In the previous one that we worked on, this board E was kind of just dangling off there, and the key contacts were all bent and needed adjustment. This one looks pretty good. The bus bar does need to be cleaned, but we can do that with this board in place. It's a huge amount of effort to take this board off and put it back on, and there's just one capacitor there. So provided that capacitor is okay, we're going to leave board E in place because it's not worth the expense of removing that just to change this one capacitor for preventative maintenance. We also have board F, which doesn't have any capacitors. But as I was taking a look at it, I noticed a cracked resistor there. So while we have this off, we're going to replace that. This is the board we're going to move to the other Pro Soloist because it doesn't have the painted switches, but it does have this broken switch. So we're going to take the white switch off the painted switchboard, and we're going to put that on here so we get a board with unpainted switches, all of the correct color. And then I'll put a replacement switch. It'll be black, but I'll put that for the portamento on the other one. I sell the replacement switches. They're really hard to find, but fortunately I have a limited quantity of those. So if the switches aren't making contact, or they're broken, or have some other mechanical failure, they can be replaced. We're going to rebuild the touch sensor bar here because the touch sensor is not responding well. And this is the power supply. We're going to rebuild the power supply and change all those capacitors on there. Unfortunately, this is a really difficult one to get out. The ARP Pro Soloist isn't very friendly to the people servicing it. The power cord has a strain relief bushing that you had to pull, and the power cord is soldered to the board, and I had to remove the switch to get this board out to service it. But it's going to be worth it, because the power supply of a vintage synthesizer definitely needs to be recapped if it hasn't been yet. So I'm going to go remove the capacitors from all these boards, and also the broken resistor there, and get started recapping this. I've got the old capacitors and sliders desoldered from the board. I need to do a bit of cleanup because it's very dirty down there. Got the capacitors off this board. Interestingly, I see that it's been worked on. There's a few op amps which have been replaced with socketed ones here. So since some of these aren't original, hopefully it'll be in better shape, so someone's worked on it. There's the power supply with all the capacitors removed. This is board D. There's another capacitor on here that isn't cost effective to replace. You can see it sticking there under this switch. To get to it, you'd either need to remove the switch or remove the ribbon cable. So unless there's some need to replace that, it's just not economical to do that as preventative maintenance. I wouldn't spend the time to do that unless the customer wanted me to. Here's board B with the two capacitors removed. The voice selection switchboard with the portamento, the broken portamento switch removed. And I've taken the not broken one off the other board to put in here. And I'm going to put a black one on the other one because that's the only color replacement switch I have. Here's the old sliders. They're really nasty. And we're going to be replacing those with LED sliders. So the next step is to put the capacitors and the LED sliders in. So I'll do that and then check back with you. I've completed the recapping of the boards and the addition of the LED sliders. Also on the voice selection switchboard, I moved the good light switch over to the board without the paint, and I put a new black switch here to replace the white switch that was damaged. I've also replaced the resistor here that was cracked in half. And I've started on the keyboard. I have the dirty keys in a bucket ready to soak in warm soapy water. And I have all the keys off the keyboard and the bushings removed, ready to level the key bed. You can see here, at least this key is going to be much higher than the other keys. So I'll go through and I'll level the key bed, and I'll clean the bus bar and key contacts and install new bushings. I have another video on that. And then what we're going to do is we're going to hook up the boards and test this out. So I've rebuilt the keyboard. I've changed the key bushings, leveled the key bed, cleaned the bus bar, adjusted the key contacts, put everything back together. I've connected all the boards. They've all been recapped. The LED sliders are in, but the power to the LEDs aren't connected yet. But before, everything is connected except for the power supply. Before I connect the power supply to the rest of the keyboard, I'm going to make sure that it's working within reason, so I don't expose the rest of the electronics to any potential incorrect voltage. So I have another video on how to test power supplies for ARP synthesizers, but I'm going to test this one real quick. So this is the multimeter. I'm going to stuff the black lead up the black wires part in the housing, and I'm going to stuff the red wire, the red probe up the purple one. So that's negative 15.21 volts, and that's the negative 15 volt rail, so that's fine. I'm going to test the orange, the orange, which is the 5 volt rail, and I'm testing 5.28 volts, which is fine. And now I'll stuff the red probe up the red wire housing, and that's 15.35 volts, and that's the 15 volt rail, so that is fine. So now I'm going to power everything down, and we'll connect the power supply to the keyboard and test it out. So I've connected the power, and then I went ahead and I adjusted the trimmers to make sure that the voltages are at plus and minus 15 volts. And bassoon is already on, but the lights are on and nobody is home. So we're going to pull out the oscilloscope and we're going to troubleshoot this. So I started troubleshooting. The first thing that I took a look at was the voice selection switchboard. I was making sure that the code for the voice that we had selected with the switches was being generated correctly, and it was. And I checked on a board down the line, and it was being passed on along well too. The next thing I took a look at was the waveform generator board, and I was making sure that the waveforms of the oscillator was working for the voice that we had selected. And I also took a look over here on board C, the filter board, to make sure that was being passed over correctly. So there's the sawtooth waveform. There's the pulse waveform. I found that this ROM here was not enabling lines that it should have enabled. I took it out and I reseated it in its socket, and it actually fixed the problem. Previously, let's see if I can find it for this one. Yeah, previously, so this is a high-pass filter line that's enabled for this voice that I've selected, which is fuzz guitar. And before I reseated the ROM, this was at 0 volts. Now you see that it's enabling this high-pass filter C. The next thing that I took a look at was this op amp here. This is the pulse mixer. There's an input, and it's I'd have to switch to AC coupling for you to really see it, what's going on there. But this pin 3, I noticed, is at 2 volts and change, and it should be ground. And what this is doing is it's creating an offset here on this signal. This should be centered around 0 volts, or it should be a 0 to 5 volt signal rather. I noticed that the op amp was replaced at some point. It was put in the socket, and it was just kind of wiggling around in the socket. So the socket was no good. I changed the socket and the op amp, but the problem persisted. With the synthesizer off, I tested for continuity between this pin 3, which should be ground, and actual ground on the where it comes in from the power supply, and there was a resistance there, so there's some kind of broken solder joint there. And I tried to track it down, and it actually affects much of board C, but I couldn't track it down very easily, and I don't want to spend any more time on that. So what I decided to do was, for testing purposes, I'm going to jump from ground to this trace here, which should be ground. And now we can go back and revisit this op amp. So pin 3 is now ground, and now the output is more closely centered on 5 volts. To give you another example, I'll show you flute. Flute, I think, is a better example. So the input signal is too low to see, but now the output, you can see, is 0 to 5 volts, like it shows in the voice troubleshooting page in the service manual. So what I'm going to do now, I'm going to remove that jumper, just so you can see that this cracked solder joint, broken solder joint, is causing a problem. So you see now it's stuck high at 15 volts. And if I change to AC coupling, yeah, you can't even see the original signal. So we fixed one problem, but unfortunately the flute still doesn't work, so there's some more troubleshooting to do. But we've taken a step in the right direction. So I've connected a jumper wire on the bottom of the board to fix the broken solder joint, and now without having a jumper wire crudely placed on top of the board, we're getting the correct waveform here on the flute. But we knew we wouldn't. We're not getting any sound. So we follow the voice troubleshooting flow chart, and this is the flow chart for flute. And it says the next thing to look at is after the high pass filter. So that's test point 7, which we can poke here on our ROM, because this is where the line gets enabled. So let's see, it's I just saw it. There we go. It's high pass filter B, which is pin 2 on this ROM, and now we're getting a waveform there that looks very much like that in the picture, that shows what we should be expecting. So we're good to move on. The next stop is right in front of the voltage controlled filter. So this is the VCF submodule, and test point 10 is the input of the VCF submodule. So what we'll do is we'll turn the board on its side like this, so we can get to the pins. We're also going to need to, it says we're expecting a 0.1 volt signal here. So let's take a look at pin 1, and there we go. Substantially looks like this waveform with a a 100 millivolt peak to peak. So next stop is the output of the voltage controlled filter, which should look like this, kind of like a sine wave almost. So the output of the VCF is right here, and we have just noise. Yeah, that's not an audio signal. That's just noise. Very low amplitude noise. So this voltage controlled filter appears not to be working. Let's verify the input voltages before we jump to conclusions. So there's the negative rail is at negative 15, ground and positive 15. We'll also need to check the control voltage input to the VCF, and I'm going to go grab a schematic and figure out which pin that is. So we're going to take a look at the control voltage input to the voltage controlled filter to make sure that it is being given a control voltage. So once again, here was our input, and this is our control voltage. So the control voltage is present, but we are getting no output. For comparison purpose, I put the first Pro Soloist board C, and since it's tied to board A, I put board A back as well. So this is the Pro Soloist number 2, and this is Pro Soloist number 1. And we can take a look at the inputs and outputs of the filter. So this is the filter input, which looks very similar to what we saw on the broken one. And this is the filter output. So the flute is making a nice sine wave like it should. The control voltage to the filter, I'll zoom back into where we were looking on the other one. So the control voltage is the same as the one on the that's not working. So it's safe to say for the other one that the 4034 submodule has a problem, and we're going to have to desolder it and try to depot it from its case to repair it. I turned the board over and started to desolder the filter module, and I noticed that there had been some prior work done here, a lot of nasty looking flux residue, and the traces of the board, sorry about the focus, many of the traces of the board had been destroyed, and then it looks like they put globs of solder over little wires that they had kind of hugging the trace and the pin. And I guess a trace here had gotten destroyed, and they put a jumper wire to correct that. I also noticed that there was rework done. It's not as obvious with the camera, but there was rework done on these pins. So I'm guessing that the broken solder, the broken trace that we saw earlier for that ground line, I'm guessing it originates somewhere under the filter. But basically, since the board has been destroyed here, I don't know why. Maybe they swapped the filter out at some point. I mean, the filter's never been opened up. But it's going to make it challenging because we have to desolder this. We have to de-encapsulate the module. Then we have to put it back to test it, to troubleshoot it. We have to take it out again to repair it, and then we have to put it back again to final test it and have it set up to go. So we need to take it out and put it back in at least 2 times, and it looks like the board isn't going to support that. So we're going to break this out into another video where we're going to come up with a solution for that and de-encapsulate the filter and repair it. So stay tuned for the next part where we do the encapsulated filter repair.